So step 2, what we need to do is draw the graph using the constraints that we just discussed. So naturally, you follow the same steps that you usually use to draw a graph. You mark the x and y axis. If you're using a graph paper, you can use the existing lines as axes. Otherwise, you'll have to draw them. And you'll have to make equidistant markers on the x and y axis based on the scale we take. Here I'm taking a scale of 10. So on the x-axis, I'm marking from 0 up to 100, and on the y-axis from 0 up to 60, and our origin is 0. Because these markings suit the points that we need that I will be using for this graph, and you mark the origin 0, comma 0, and then when you substitute in the equations, you get the points 30, comma 0, 40, comma 0, 0, comma 40, and 0, comma 60. So uh, we spoke about some constraints earlier, right? When we solve them two at a time, these points x equal, since x equal to 30, y equal to 0, x equal to 40, y, these are the common points that we're getting. So we use them to mark the constraints given. When we substitute x and y equals 0, we get these points and the lines, and then using those points, we're drawing the lines. To find the common point of to find the common point of intersection, we solve the two equations, and we can see how to do that. I've shown you the steps. Multiply by 2, subtract. We get 20, comma 20 as the common point. Now the 4 points, that is the we need to mark out the 4 points of the corner point table, and yeah, the shaded region that you can see here is the feasible region we're getting, because based on the inequalities, both of them are lesser than or equal to constraints. So the region that's lesser than or equal to both the lines is that region. Now these 4 points of the feasible region form the corner point table. That is 0, comma 40, 20, comma 20, 30, comma 0, and 0, comma 0. We now need to solve for these points in the objective function, and see where we are getting the minimum or maximum value depending on the problem. So now we need to use these 4 points to form the corner point table. So we make the corner point table. Always remember that when you try to substitute the values in the objective function, you need to remember if the question asks you to minimize or maximize. So here when we substitute, we're getting 0, 40, 180, and 240 for the 4 points. This is a maximization problem. The maximum of these four values is 240. This means that at the point 30, comma 0, we obtain the maximum value of 240. Now let's try and understand this with the help of a sample maximization problem. So we'll list out our constraints based on the question maximize z equal to 8x plus y. That's the first step. Next, once again, we need to draw the graph using these constraints. So what do we need to do for that? We should find at least 2 points on each line. So we have the three lines that I stated, x plus 2y equal to 40 and so on. Why are we finding this? Because using these points only, we can draw the lines on the graph. So we found points 0, 20, 40, 0 on the first line. Similarly, we find for the other two lines also. Now using these 6 points, two for each line, we can find one or more points on the line if you want, but we need a minimum of 2 points to form a line. Now we need to plot the graph. So once again, we mark our x and y axis, and then we uh, mark out equidistant points. If you have a graph paper, you can use the existing 1 centimeter differences. Otherwise, you have to make some equidistant scale of your choice, and then you need to choose a scale depending on the problem. Once again, I choose to take a scale of 10, and I'm marking from 0 up till 100 on the x-axis, and 0 up till 60 on the y-axis, and I'm marking my origin 0, comma 0. Now I need to mark out the 2 points, the points I got on each line, so that using these I can draw my lines. So the points we got were 10, comma 0, 15, comma 0, 40, comma 0, and then 0, comma 20, 0, comma 30, And finally, we need to draw. We have a common point 0 comma 20 which lies on two lines, so we have only 5 points. And now we draw the lines. So based on the constraints, the first line is less than or equal to. That means that it is the region denoted by the lower arrow, that is below the line. For the other two lines, the the constraint says greater than or equal to, which means it is above those two lines, represented by the two upper arrows. So the common region is represented by the middle polygon, and we need to find the corner points. Once again, we have two other points of intersection which we need to find, uh, because these do not lie on the axis. So we need to solve the two respective lines to find them. So to find one of the points of intersection, that is of the line 3x plus y is equal to 30 and 4x plus 3y equal to 60, we solve the two lines and then we get 6 comma 12. That is one of the points. Similarly, we can solve for the other two lines, and we will get another point of intersection. This point of intersection, as I said, is 6 comma 12. The other point of intersection is 4 comma 10, 18. So now we got the 4 points, corner points of a corner point table. These are the points that basically these are the corners of the polygon, that is the feasible region. The feasible region that is enclosed between these three lines mutually. The corner points of it are 4 comma 18, 6 comma 12, 40 comma 0 and 15 comma 0. We need to make a corner point table using these points, as I said. Once again, substitute them in the objective function, and this is also a maximization problem. So we need to find the maximum value. So this is us forming the table. We draw a table for our convenience and we substitute in the objective function the 20x plus 10y. Values we get are 300, 400, 240 and 260. But yeah, sorry, it's a minimization problem. So we get the value 240. That means we get a minimum value of 240 at 6 comma 12, at the point 6.